2012, during a water quality survey of Lake Geneva, researchers from the University of Geneva discovered for the first time spherical mineral inclusions of amorphous calcium carbonate in the intracellular space of diverse planktonic microorganisms. These mineral spheres were called micropearls, and we know today that they are the result of a biomineralization process that had been overlooked in the past and take place in diverse eukaryotic microorganisms. Among the different organisms forming micropearls, several species within the widespread class of green microalgae Chlorodendrophyceae have been shown to form a very particular type of micropearls, micropearls in which high concentrations of strontium are accumulated. This observation indicates that this group of microalgae can specifically concentrate strontium by sequestering these elements from the environment, which makes them very interesting candidates for the development of new bioremediation techniques. If you are not familiar with the term bioremediation, it is the process by which living organisms are used to remove or neutralize an environmental pollutant. Although natural isotopes of strontium present low toxicity, the radioactive isotope strontium-90 is one of the most harmful radionuclides that have been released into the environment after nuclear accidents such as Chernobyl or Fukushima. Today, radioactive contamination is still a real threat, and the traditional techniques to remove radioactive contamination have technical limitations and high economic and energy costs. It is therefore necessary to work on new efficient techniques to treat this type of contamination. Thanks to the Gebert Rüf Stiftung, over the last 4 years we have been able to study the mechanisms underlying the micropearl formation process and the strontium uptake capacities of these microalgae, which in turn has allowed us to critically assess the potential use of these organisms as bioremediation agents. The results obtained from this research are highly encouraging. Our experiments have shown that these microalgae have an extremely high capacity to remove strontium from water, including the radioactive isotope strontium-90. In addition, several microalgae species within the class Chlorodendrophyceae are easily grown in large-scale culture systems and therefore particularly attractive for new bioremediation methods. Through the experiments we carry out with microalgae cultures in laboratory-scale photobioreactors, we have been able to determine the optimal culture conditions to maximize the strontium uptake by the microalgae, and we are now certain that the implementation of an industrial-scale decontamination system with these organisms should provide successful results. The use of species within the class Chlorodendrophyceae for the development of new techniques for strontium-90 decontamination presents several advantages compared to the use of other organisms suggested in the past for this purpose. Indeed, the strontium absorption capacity is shared by species living in very different habitats, including hypersaline water, seawater, brackish water, and freshwater, and therefore they could be used for strontium-90 remediation in very diverse aquatic environments. In addition, some species show high growth performance in a wide range of salinities and light intensities, which further increases their field of action. They can also be highly resistant to bacteria and cyanobacteria contamination, which is an essential requirement for these organisms to be used for the treatment of non-sterile water. Another advantage of using these microalgae over other types of organisms is the low energy cost associated with their production, since natural sunlight can be used as the main source of energy for growth. Currently, several outdoor photobioreactors for large-scale production of Chlorodendrophyceae microalgae exist and could serve as basis for the future development of industrial-scale decontamination systems. We hope that the results of this research will be soon applied for the conception of innovative bioremediation techniques adapted to the new needs of our planet.